Okay, in this video we are going to apply the equation of Venturi meter that we have derived from the Bernoulli equation for this example. Here we have the Venturi meter coupled with the manometer. We have two sections here, from the inlet to the outlet at the throat, and then we have also another section at section 3, which is this is the exit of this pipe. Okay, so the question given the oil as the fluid pass through the pipe with Sg 0.85, and then the manometer use the mercury as the fluid, Sg 13.6, and then we have the inlet velocity of 2 meter per second, inlet diameter 120 millimeter, the throat diameter is 60 millimeter, and this is D3, 100 millimeter is the exit diameter for this pipe. Okay, so the first question asks for the H, determine the H hash in the YouTube manometer. So by using the previous equation that we have derived here, which is V1 equal to A2 over square root A2 square minus A1 square, then we have 2G hash bracket rho M over rho W minus 1, where this rho W can be replaced with other fluid that is passed through the pipe. So here we will replace the water with oil. So we write again the equation V1 equal to A2 over square root A1 square minus A2 square, then you square root again 2G hash rho of the mercury inside the manometer divided by rho of the fluid. So the fluid is replaced, instead of water we use oil. Okay, minus 1. Alright, we will use the information given here. So we will square root all of these terms. V1 square equal to A2 square A1 square minus A2 square bracket 2G hash rho M over rho oil, sorry, minus 1. Okay, we want the value of hash here, so we rearrange the equation. Hash equal to A1 square minus A2 square over A2 square multiply with V1 square, and then divide by 2G. Okay, and then we will multiply with or divide by rho of the mercury divided by rho oil minus 1. So what is the value that we will get here? A1 is pi d1 square over 4 minus pi d2 square over 4 over pi d2 square over 4. So this is the first terms. This is V1 square over 2G. Then we can also rearrange this. Okay, put on the upward here. Rho oil over rho M minus rho oil. Okay, now we will simplify it. So becomes, sorry, pi d, right? So we have d1 square minus d2 square over d2 square, then we multiply with v1 square over 2g. Then this is raw oil, but we can convert it into SG. SG oil multiply with the density of water, and then divide by SG for the mercury, density of water, minus SG for the oil, density of water. Okay, so density of water can be cancelled out. Now it becomes SG only. Then we put our value here. D1, diameter 1 is 120 millimeter. Convert into meter, it becomes 0.12 square. Then D2 is 0.06 meter, okay, square over 0.06 square. Then multiply with our inlet velocity. V1 here is 2 square over 2g, and then our SG oil is 0.85 over 13.6 minus 0.85. So what you will get is this is 3 multiply with 4, 0.2039, okay, 0.06667. Okay, you get here 0.04078 meter, or when you convert into millimeter, you get around 40.78 millimeter. So this is question number 1, or A. As for the H, then for the question number 2 here, it asks for the velocity of the oil in the throat, means that it asks the velocity at section 2. Okay, so for this question now, I will change it into the smaller one. Oh, sorry. Our answer is here for question A. Now for the question B, in order to get the exit velocity, we can apply the continuity equation. From continuity equation, from the first point also the second point, A1 V1 equal to A2 V2. We have already the velocity at point 1, so for the velocity at point 2 here is equal to A1 over A2 multiply with V1. So here pi d1 square over 4 divided by pi d2 square over 4 times V1. Then this can be cancelled out. It's equal to d1 over d2 square V1. So our d1 is 0.12 over 0.06 square, and your inlet velocity is 2, so you will get the value as 8 meter per second. Then for the third question, velocity of the fluid at the exit of the pipe. Also we can use our continuity equation. This time you can use from point 2 to point 3, or also you can use from point 1 and point 3. So let's say I want to use from point 1 to point 3. Okay, 1 3. So a1 v1 equal to a2 a3 v3. So here, in order to get v3, you have a1 over a3 times v1. So the inlet area here is pi d1 square over 4 pi d3 square over 4 times v1. So same case as the previous equation, d1 over d3 v1. So your inlet diameter is 120 millimeter, 0.12, and the exit diameter d3 from the equation is 100 mm, 0.1. So we have sorry, here we have square, so your inlet velocity v1 is 2. So what you will get is around 2.88 meter per second. So that's all for the question related to Venturi meter.